There's no but.
Really? Okay. I thought it was.
So welcome, guys.
Hey, Mariah.
I'm so glad that you care that I'm here.
Great.
Welcome to the Cool Meetup for this month. It's the last one of the year. Yay! I think it's my last meetup of the year. That's actually really exciting.
I didn't mean to clap at that.
Fine.
I know you. Yeah, I know. We were just excited.
So we're really excited about today. Just a couple notes. There are 10th anniversary pins on the table. They were supposed to be here for the 10th anniversary party last month, but that didn't happen, and it's not my fault. It's actually Google's fault. So you can blame Google for that. They're horrible at shipping. They should have left that up to somebody else. Yep, that too.
Advent code.
Oh yeah.
It's not on the board, but you should talk about it.
Well, it's because I'm too busy. So we're having the advent of code. If you want to instruct the people as to where the door is, going on. Clint's organizing that. You can find out all of the information you need to about that through the GoLink Slack channel. Here.
Just a private leaderboard, so.
Yeah, there is. We have our own leaderboard going on. And I thought Clint had prizes or something. I have no idea what Clint's doing, but Clint's in charge, so you can spam him.
That's dangerous.
Clint being in charge is dangerous. I agree. So you can spam him about it. There's quite a few people participating in it. They were talking about it today, about everybody's solutions. So super fun. Make sure you join that. And just a reminder, we have a conference next year, May 8th. It'll be at the Jordan Commons Megaplex. We're looking for speakers. We're looking for sponsors. We don't have tickets up for sale yet, but I will let everybody know as soon as that happens. And I think that's all of my things. If you have any jobs, please post them in Slack. If you have any commentary, you can tell Matt or post them in Slack. And make sure that there's no food left over when you guys leave. Okay, that's all I got. So I'm going to turn the time over to Matt so he can talk about all the cool things he has to talk about today. I don't know how many cool things he's got, but he says it's super awesome.
He's only got cool things.
Matt! All right.
So give him a round of applause. Now the question is, how smart is the TV? Oh, it's smart.
Okay.
That worked out pretty good.
Cool. Just find my controls here. Okay.
Is that working? I have another one if you need.
No, we're good.
Okay.
Okay, that'll work.
If you want this printer to work.
Yeah, no, just in case. Okay, so hello everyone. I've actually, just to be safe, I've written out my talk. I'm going to try not to read the whole thing, but the reason is this talk does assume intermediate to advanced Go experience, so I'll go over a lot of stuff and it's kind of technically dense. It's also my first time giving this talk though, so if something doesn't make sense, feel free to like interrupt me. And
So you're gonna put it, oh wait, you can't put it in the CSE conference because you're reviewing it.
Yeah. So you don't have to ever hear this again. Throw tomatoes at me or salsa or whatever you got on your plates if you don't like some. Those of you who are joining via stream, I hope you can hear me. I have no idea how well it works.
Really well.
Okay.
The mics pick up whispers.
Great. So anyway, welcome everyone. Now, if you don't know what Caddy is, if you don't know what Caddy is, go to caddyserver.com right now and just kind of skim the homepage and figure it out. You just need to know that it's an easy-to-use web server. It's very extensible, rip and go, good general-purpose server. So I'm going to talk about the design of the server today and how we kind of solve some, I thought were kind of some interesting problems. Very kind of high level. These are very general problems. So to begin, let's go back to 2014. I was a CS undergrad at BYU. My hardest semester, I was in 400 level CS classes, which I needed a web server that didn't exist. And Go 1.3 was just released. 1.3, that was like 5 years ago. How many of you used Go 1.3? How many of you even, I know you two. Everyone else is newer to Go. That's great, that's great. Anyway, I've been using it for a few years at that point already. So I spiked out a new web server and I made the first commit after about 3 months, after about 6, which was also the first day of Let's Encrypt's public beta. I added automatic HTTPS, becoming the first web server and still the only one to my knowledge that uses HTTPS automatically and by default. And after 18 months, Caddy was endowed with primitive plugin architecture, allowing people to extend it with their own Go packages without bloating the project or without compromising the benefits of Go's static binaries. So Caddy grew to have over 100 plugins, most from third-party developers, which made it super useful for a lot of people. In the last few years, Caddy's managed over 1 million TLS certificates, including like automatic renewals and stuff. Secured over 250 billion TLS connections and served over 1.5 trillion requests. And that's 0.1% of the actual numbers according to our best estimates. Now Caddy 1 was largely successful because of its simplicity. So if you've used it, you've used the Caddy file, you know that it's really easy to configure. It's kind of was its main selling point. But our emphasis on simplicity was crippling, actually. First, because this easy or good for beginners focus lowered expectations kind of all around. We found that users were less likely to read documentation and to put in more effort to actually learn how things worked. And that ultimately hurt the users and the maintainers of the project, would frustrate, you know, and it would just kind of hurt the whole community a little bit. And second, because that simplicity was integrated too close to the core of the software. It was integrated at the wrong spot. So it wasn't flexible enough to do anything beyond simple things, and it wasn't useful in the space where people actually needed solutions. In some ways, simplicity is better, but in other ways, it's not. Like a simple, short config file has a lot of hidden magic. That's true. It's easy to write, but like more obscure to like get anything useful from it. So it's good and bad. Now Caddy worked well for a couple of years, but issues kept piling up. And it became clear to me that Caddy was not fit for prime time, heavy duty enterprise use, especially in like a hostile, evolving cloud native environment or ecosystem that didn't really exist before. These are a few of the feature request issues that I just randomly sampled from our repo over the course of Caddy 1. So what happened is I gradually made plans for version 2 that would totally replace 1.0 before we even reached 1.0. So I committed to building 2.0 late last year, and I tagged 1.0 as kind of a formality just so I could start on 2.0, and because that's the web server I always wanted to build. After a few months of intense design work and spike coding, I was able to close 1/3 of all open issues immediately. Here's some of those that were closed, just some of them, because of the new design alone of Caddy 2. I was able to immediately close all these issues, including some issues that existed since day 1. Issue number 8, Kelsey Hightower's request for an API, which I attempted several times in version 1, but failed. You can see like some of my documentation and some of the attempts over there, but it was terrible. And another 1/3 of issues were closed with Caddy 2 development, totaling about 100. And the version 2 design has the capacity to close all the remaining node issues and feature requests. So here are some of the notable ones, some of the improvements that we made. Kind of just take a look here. Now, unlike Caddy 1, Caddy 2 is not a toy project like it was when I was an undergrad. We designed Caddy 2 from the beginning as a serious server platform and a contender to whatever other web servers you're using currently. In addition to an all-new API-oriented design with dynamic configuration, Caddy 2 sports the latest improvements from the Go standard library. So we replaced all that Go 1.3 era stuff with shiny new Go 1.13 counterparts. And we've also partnered with Arden Labs for funding and business support. So if your company is using Caddy, you should talk to us. We'd be happy to support you. And if not, I'm going to put in a plug. You can sponsor me on GitHub as well. So. Okay, so we had talked to numerous CDNs and other large tech companies that use servers who were interested in a caching proxy like Caddy 2. Their requirements were pretty demanding. It was intimidating. How would we build Caddy 2 to handle hundreds of config changes per minute over the wire with thousands of parameters at play in a highly concurrent environment that demands minimal latency? Where you can't leak resources and you have to make sure there's no race conditions, and you have to leave your config always in a consistent state and have a consistent view of your config. It has to be observable, scriptable, and it has to run in a cluster. So what design did we come up with that meets these demands? Well, I will show you because Caddy 2 is open source. So, but first, let me show you how to use Caddy 2 real quick. Since we're still in beta, I'm guessing most of you haven't played with it yet. So you'll use Caddy run to start the server, and it just does nothing when you first run it. So without a config, Caddy won't do anything. There are no config files in Caddy 2, but instead you post a JSON config to its API. That's its primary mode of configuration. That config will immediately take effect. And then if you want to use config files, though, CLI does support this. It wraps the API interaction for you up in a big flag, so you can still use files with CLI. Now, there's even this thing called config adapters in Caddy 2, so you don't have to use JSON for your configuration. Even though that's its native format for config, you can use adapters to make your config in any format that you like, and it will convert it to JSON for you under the hood. So this works for the Caddy file. You can use YAML, you can use TOML, you can use JSON with comments and even more. You can even use an Nginx config with Caddy, which will translate to JSON and just like that. The Nginx adapter is a work in progress, by the way, so if you are interested in that and working on that, should help us out. That'd be a lot of fun. Okay. So the actual JSON config structure looks like this. And because Caddy is extensible, parts of its config can be fulfilled using plugins, or as we call them, modules. For example, here is a simple HTTP server that listens on port 80. And the green highlight here represents the config for a module, in this case, the HTTP server module. Now, extending this further, here's a simple file server on port 443. And because it matches requests to example.com, the server will use HTTPS automatically and by default, just like you'd expect from Caddy, and should expect from every web server to use privacy by default, but it's still the only one that does it. Anyways, because it matches requests to example.com, it can get a certificate. Oh, and then the highlights are different modules as well. So in the green, you've got the HTTP file server handler module, and in yellow, you've got the request matcher module that matches on the host name.
You know which module is going to parse which section of config?
That is a great question. Hold on to that, because that is the bane of my existence for the last like 6 months, is figuring that out. So I'll show you how you figure that out, how to build in one of these configs later. real quick, I'm going to demo this though in my favorite client. Can you see this? Okay, so I'm going to start a server real quick. Okay, so I have Caddy 2 running, and which you can't see, that's fine. I'm going to first get its config. And as you can see, there's no config. Now I'm going to use the API to the load endpoint to give it this config here, which is very similar. It's just a static file server listening on port 8080. So I'm going to send that. 200, that's a good sign. But I can go back and get the current config. I can export the config that Caddy's currently serving. And you can see here my config that I gave it. I can try it out. You should see a file listing of my desktop. Okay, cool, so that's working. Well, now let's suppose that I don't want to listen on port 8080 anymore. Let's suppose I'm really opinionated. I want to listen on 8081. Well, I could take this whole document and change the port number and resubmit the whole config, or I can craft this little request to that particular path in the config. Sorry, you can't see the whole thing there. And give it just the new listener address. So you'll notice here, the path would be apps, HTTP servers, example, listen, and then it's the first or the index 0 listener address. So that's what my path is in my URL. Apps, HTTP servers, example, listen 0. So I can send that and get the new config. And you can see that it's now 8081. I've changed just that one little part of the config. This is really useful when you have, let's say, a proxy configured and you want to like add an upstream to your proxy. So if this monitor is kind of laggy. So sending this request again will fail because I'm no longer listening on that port. I can change it. It's on the new port. There we go. I can also export just a particular part of the config, file server in this case, because I gave it an ID in my JSON. So I can directly reference that in my URL path up here. So that's kind of nifty too for handcrafting requests. I can also unload the config and stop serving it, and I can shut down the server, which will actually kill the process entirely. And you can tell it worked because the server returned. So anyways, that is kind of an overview of Caddy's config. Trust me, you needed to know that for the rest of this. And we just did that. Okay, so the first major question in building Caddy 2 was where to begin. This is the answer. I had an empty func main and nothing else. So what is the first thing that a program like this needs? Well, it needs configuration. So in V1, configuration was scattered through command line arguments and environment variables and config files, potentially multiple config files. And it led to a lot of kind of, what do they call these in stats? Like hidden variables or emergent behavior, things that would like affect the server without you knowing about it. So we got rid of that. And all the config is going to be in just one place, and that config has to be input through the API endpoint. So I started working on a little REST API, a little listen and serve handler, and this is actually how Caddy 2 started. Next obvious question is, well, what does the config look like? What is my input going to be look like? Excuse me. Now I spent considerable effort here evaluating imperative and declarative languages for starters. An imperative or a scripting language is appealing because of its expressive power, but the cognitive overhead required to like figure out what's going on is too costly. You have to like evaluate the output in your head to know what its output is. And additionally, we still needed a way to simply state what the server's config actually was, kind of like you just saw how we exported its config with a GET request, and only a declarative language really made sense for that. We also decided that a declarative format could embed imperative ones for runtime evaluation, so you get both that way. So it was going to be a declarative language, and then I'll spare you the chase and just tell you I settled on JSON. And I do say settled. I know it's not perfect, but because we have config adapters, we don't have to argue about which config format is the best. I chose JSON because it's ubiquitous, it's human readable, it's easy to tweak by hand, it works with every other config format because it's often a subset, and it's web friendly, and it maps one-to-one with the actual data structures in memory, which is very useful and very powerful idea. Okay, so we know we're going to have JSON as the input. So the next question is, how does the configuration work? What does it mean to apply a new configuration? Like, what does that look like in your program? Or to change a part of it? The servers are concurrent, so you need synchronization. If we have an HTTP handler like this file server here, it has some state on it, and every request will reference this state so that it can handle the request properly. I mean, what do? Do we have a mutex for every parameter like this and obtain a lock every time we do a read? But that also means that we can do a write and change it safely. Or do we put like a go routine in a loop and kind of dole out copies of parameters via channels or something for every read? The question is, how do we change a running server's config out from under its feet? Let's start at the end. Well, it's like pulling the tablecloth out from under your place settings, like while you're all eating dinner, and replacing with a new one without your guests ever noticing that you did it. If you're not careful, your code will have results like this, because servers are really they're very hostile, like as far as config changes go. What you really want is something more like this. And this is actually what we ended up achieving in Caddy 2. Yes, very nice. Oh, I know that this one's just fun. Look at that. Look at that guy. Yeah, ours is even smoother though. So anyway, it quickly became obvious after playing with this for weeks that each parameter having its own mutex or channel is like really unwieldy and severely limits performance. It's also prone to race conditions and leaking memory, ironically. And any area of the config that is affected by a change, there was no way to like notify that part of the server that something had changed. Sometimes, for example, if a new backend is added to the proxy or a listener address is changed, the server actually needs to proactively respond to this change. So it turned into a two-way data binding problem, which if you're familiar with any front-end development, it still plagues DOMs to this day on web pages. So we avoided that. And a better design, it turns out, is counterintuitive, but refreshingly simple. We don't use locks. So wait a second, how do we safely change a highly concurrent value without locks? Well, we don't. We treat a loaded config as a single immutable atomic unit. This decision takes inspiration from strings in Go, where changing even one byte of Go string will yield a copy of the entire string with the new value. Similarly, changing one part of a Caddy config yields an entirely new value which replaces the previous one. This is actually faster because Go's garbage collection is highly optimized and mostly non-blocking. So all we have to do is take the old config out of scope and it will get garbage collected. And this is a lot faster and easier than using locks all over the place. It only requires a copy for changes, not for reads, because servers are very read heavy on their units. Very read heavy. Config changes are done in the background, so allocations aren't really a big deal, and so this garbage collection is really a non-issue. So that was a huge, huge advancement in my way of thinking about this problem. So at this point, we've established, I know I'm moving super fast. You guys can always interrupt me, but anyway, we've established there will be a single config structure that will be filled via JSON, like this. That little box up there is a lock over that particular config pointer. We'll keep a pointer to this config and replace that pointer entirely when there are any changes to it. So what if we want to change this one little part of the config then? So this is the next problem. You saw this in a little demo when I changed just the listener address. Now we could compute the new config ourselves and post the entire thing. That's kind of tedious. It'd be much better if we could just use the URL path to traverse into the JSON structure to a specific point and perform an operation using the request body according to the method. Now, at first, this was a really daunting visualization. That's actually what it looks like. This is a really daunting kind of task to like figure out, because how do you traverse these kind of arbitrary values in memory? In a memory-safe language where you can't do unsafe arithmetic and all this stuff. But soon, a fun and elegant solution came to light, and it goes hand in hand with the decision to make configs immutable. So the way we do this is before we load a config, we simply decode a copy of it into an interface, an empty interface. Now what this does, if you've done this before in Go, you probably have, is it produces a generic recursive structure where objects become map of string to interface and arrays become slice of interface. And everything else is just an interface, integers, strings, everything. So we can then represent paths into the structure easily enough. And as you can see in this slide, we have this little for loop that just splits the URL path. Does it have a laser? Yeah. Great. Was that button?
It's a,
Oh, cool. It's a TV, so you can't see the laser. That's fine. Just look at it. So you can see we split the URL path by its slashes, and then for each part, we just look at the current pointer into our object, and if it's a map, we go into that key, and if it's a slice or an array, we go into that index, and then it's really easy actually. And then we can perform whatever operations deep within the structure we need to. And the cool thing is that if you decode into an interface, you can encode as JSON into an interface, and so you get your whole new config out of it. Only one brief lock is required for all of this. If the config loading fails, we just have to restore the previous representation so our view of it remains consistent with what's actually running. So that's kind of the big secret for these little changes. We just have a copy of the config that is in a generic format like this, and we can just mess with it all we want on the side. And as an added bonus, this also lets us export the current config, again, because it encodes JSON the same as it was decoded from it. Okay, so we have this config, and we can change just certain parts of it. So that's awesome, but how does loading it actually work? When we want to start using it or replace an old one, what is that actually, what happens? Well, the naive approach is like this. We stop the old one, shut down the running servers, whatever, and then start the new one. Caddy used to do this way long time ago, like back in like 2015. It used to do this because it's easy and it works. But the server incurs downtime, which quickly learned was not acceptable. But somehow, some of the resources are saved from the old config, like listeners, literally everything else, needs to be transferred to the new one. For example, you have a proxy that has state about its upstreams from health checks. It needs to transfer that to the new one. Or if you're doing rate limiting, you can't just forget all of your throttles and open the fire hose when you load a new config. You have to transfer all that to the new config. But you also have to discard everything the new config does not use. So if the new one, like you saw when we did our demo, we didn't use the old listener because we made a new one at a different port. So if the new one fails to load, though, we need to relinquish those resources back to the old config and pretend like nothing ever happened. It's actually really complicated when you think about it like this. I've tried several approaches for having the config share state. And I'm kind of shivering just thinking about it because it was really complex and error prone. And sure enough, having two configs talk to each other was really not working. It didn't scale well as the config grew, and it didn't play well with plugins, which I'll explain soon. No, for sure, configs would have to run independently of each other. And only the core of Caddy really even knows about the two configs. But because of Caddy's modular architecture, its ability to peer deep inside either of the configs was severely limited, even impossible. So it can't know which values need to be transferred to the new config. You'll see what I mean about that in a few minutes. But after some serious thought and refactoring, we came up with a somewhat clever but elegant solution. Not that. That one. We run 2 configs at the same time. So we start the new one before stopping the old one. And we only stop the old one after the new one starts successfully. So they're able to share resources and clean them up if they're no longer needed, but neither config ever know about each other. There's no explicit cross-config communication, yet the second config is able to bind the same network sockets as the first one. For example, while sockets that the new config does not use get closed after the first config is stopped. Does that make any sense? The new config and the old config are both running at the same time. They don't know about each other, but they don't step on each other's toes either. So how is that possible? Well, this time we took inspiration from reference counting garbage collectors. The basic idea is to count, I do have a slide for this question. Basic idea is to count how many references there are to a particular value. If the count reaches 0, the value can be deleted. Whether we like it or not, some state is just global. So huge goal here is to avoid global state because for obvious reasons, bookkeeping is difficult. So it's easy to leak those resources, share them improperly. But like network sockets, they're global. Like you got one for your system, one at a particular address. Proxy upstreams, you got one. No matter how many instances of your config are referring to that proxy upstream, it still has one state, you know. So these are global values that you just have to share. And if you try and bind a socket that the first config is still using, it's going to fail. So what do we do here? Well, it created a type called usage pool to help Caddy share config, configs share state globally. Now, a usage pool can safely be a global value, so it's okay to make these global because it's just one of them, and they're thread safe or whatever. So when a config is loading, it can get a needed value from the pool via the type's atomic load methods, loader, store, loader, new. If the value does not exist in the pool, it will be stored or created then stored. Then the value will be returned. When a config is stopped, it simply calls the delete method on this type. And under the hood, delete actually just decrements the counter. But if the count reaches 0, then it actually deletes the value. Now, this works not in spite of overlapping configs, but because we run 2 configs at the same time. The configs never know about each other, and global state is properly managed. So anything they would need to share, just put in the usage pool. You don't have to think about it anymore. Here's a quick look at the pool's implementation. I won't bore you with this. A lot of locking and counting. Yeah, it's basically a sync.map, but with a few little tweaks. Yeah, this is what it looks like in practice. Here's actually a screenshot from the reverse proxy that is trying to get the state of the upstream hosts that it needs to load balance to. So for example, if an upstream host is down, it should know that right out of the gate instead of having to discover it for itself. So all it does is it loads or stores it from the host variable, which is the usage pool. And if it loaded an existing one, it uses that. And if it didn't, it uses the one it made. Like it's super simple. And then when the proxy is closed, it just calls delete on its upstreams. And everything just takes care of itself. Sorry, I'm getting over a cold, so my voice is a little rough. Now, I know what you're probably not thinking, but what about plugins? That's what makes Caddy cool. So let's talk about plugins. Now, Caddy plugins are called modules in Caddy 2, despite the unfortunate name clash with the term Go modules, which emerged around the same time. I'm so sorry for that. They're not related. I may use the term plugins and modules interchangeably in this talk to refer to Caddy plugins. So Caddy plugins are used by importing their package and then recompiling. That's it. It's really that simple for users. And our website does this for you automatically, so you don't ever have to do this if you don't want to. Now, as a side effect of importing, a Caddy plugin will register itself with the core of Caddy, and then it can be used in a config. So I'll show you this simple example of our Gizmo module. You can see in blue that it registers itself. And all Caddy modules they also implement the caddy.module interface, meaning they have a method called Caddy module that returns some information about the Caddy module. That's in yellow. You can see the module has a name, which is lightly structured. You can see that it's an HTTP handler module because it starts with HTTP.handlers. Very self-explanatory. If any part of a module can be implemented in different ways, then that part should also be a module. And this is kind of crucial to understand. So a module has a field. You see our gizmo struct has a JSON raw message field. That is where a module that does something, some gadgety thing goes at first. And it's this module's job, the gizmo's job, to load that module when it starts up and to put it in the gadget field below it, where it can be used. The module fields have a type of JSON raw message. You can see that it also has a Caddy struct tag, which helps Caddy to know what kind of module to expect there and how to get the name of the module so it can load it. So the Caddy struct tag is used for loading the module. But this is all done for you. You just have to put it here in code. So Caddy's config type, this one, is the top of the module tree. You just saw how a module can contain other modules. The very top of this tree is Caddy's config. So the core of Caddy knows the concrete type definition of a config to a certain extent, but where a parameter can be satisfied by a plugin, the type becomes a JSON raw message, and anything beyond that point remains opaque to Caddy. So you can see the first two fields, admin and login, are concrete types that Caddy knows about. But storage raw and apps raw are modules because storage can be implemented different ways and apps do different things. And so these are JSON raw message fields with their corresponding Caddy struct tags. Caddy has no idea about HTTP servers or TLS or anything like that. Sounds kind of weird to say that, but that's true. So at its core, all Caddy knows how to do is load its top level modules called apps and call start and stop on them. That's all it does. That and like switch the config for you. In fact, Caddy can run any Go program that can be started and stopped, so it's really an excellent platform upon which to build any Go service. So think about that because you get the benefits of this config. It's going to take care of itself for you. So now that you know about modules, we need to explain how modules and the config life cycles that we talked about are related and how we manage modules through config reloads. The tricky thing about all this, remember, is that modules, you don't really know what they are or what they do. They're just JSON raw message, which is a byte slice to us. So what happens is that first the top level config is decoded. It's JSON unmarshal into config. That's what happens first. This populates some of the config parameters like admin and logging, but leaves most of it in JSON raw message fields. So Caddy then fires off a recursive chain of load module calls. Yeah, so step 2. This recursive chain of load module calls will unmarshal the JSON raw message into the instance and then call the module's provision and validate methods so they can set themselves up and make sure that they are good to go. And then returns the prepared module as an interface. Usually this empty interface is then type asserted into a more specific type that can actually be useful. So this sequence is recursive because notice in step 5, the provision phase, modules will typically call load module for their own JSON raw message fields, which in turn calls provision, and so on, until you reach such basic functionality that there are no more modules. By the time the first call to load module returns, all of its submodules have been loaded, provisioned, validated, and are ready to go. I'm almost done, believe it or not. Yeah, really almost done. Now, I hope you might be thinking, this is all impressive, but when it comes down to it, the config is complicated and Caddy is no longer easy to use. How do I know how to build this complex JSON config structure? Sayonara, I'm headed to Nginx or Apache or whatever other server is easier to configure. Who's with me? So before you jump ship though, hear me out because you don't have to, that's not relevant. You do not have to learn the JSON structure at all. Remember that Caddy 2 has config adapters, which can take any config format and convert it to JSON for you. So if you want to use the Caddy file, use the Caddy file. You lose a little bit of flexibility, but like for most people, the Caddy file is fine. You can even use it through the API. If you want to use YAML and then get a headache, use YAML. You can use your old Nginx config if you're too lazy to switch it over. Again, that's still a work in progress. That'd be so cool to help us finish it. So with Caddy 2, you can use literally anything you want to configure it, and you can use its API for these real-time online changes. And anyone can write config adapters, so if there isn't one that you want to see, just write it. Some config adapters are just like 5 lines of code because it's like JSON.unmarshal and then it's YAML.marshal and then return bytes. Like sometimes it's just that simple. So like anyway, just go ahead and write one. So believe me when I say though, Caddy 2 is as easy to use as Caddy 1, and it's even easier for many things. But this usability, we layered it on top instead of putting it in the core, which avoids all the pitfalls of our approach from version 1. So then to wrap it up, Caddy 2 is fundamentally more than just a web server. It's a server platform. I mean that any long-running Go program is better as a Caddy 2 app. It's the most programmable web server and proxy and the only one to use TLS by default. So in a day when your infrastructure, and I talk to you guys about this every time I come to these meetups, about how complex your infrastructure is and how it's growing and it's hard to manage, well, Caddy 2 aims to simplify your stack and to have fewer moving parts. There's less to manage, less that can go wrong, and it saves time and money. And it consolidates all your config and workflow into this one streamlined open source system. Of course, it's ready to go, so it's basically immune to memory-related vulnerabilities, and it compiles for anything, it has no dependencies. All you need to do is learn how to configure it. Which reminds me, oh, hey, look at achievements. One more thing, there we go. Reminds me of one more thing. I want to show you something that I've been working on for the past few weeks. So if you sit down right now to craft a Caddy 2 config, you'd pull open our ad hoc 65 kilobyte wall text GitHub wiki page, which I'll try and show you. This guy. This is where you learn how to use Caddy 2 right now. And you have to hope that you can figure out which modules go where in the config. I'm almost halfway.
That's really long.
It's took me months to write this.
I thought you said your documentation was awesome.
It is.
It is awesome.
This
This
is,
is long.
this is the beta documentation. Now let me show you what we are building. This is cool. So also it's complicated because it's extensible, right? Like you could write a Caddy module and we have to somehow like tell people how to, like we have to document how to use it. How do people know they can even use your module in a certain place in the config? Let's say you write a storage module so that Caddy can store stuff on Redis. Well, you have to either add it to this little wiki page and people have to find it, or as it turns out, the module architecture we discussed tonight makes it possible to automatically generate documentation for the entire structure, including all plugins. And you can explore it interactively in your web browser. So we can document the entire Caddy ecosystem automatically with the push of a button. It's kind of squished over there to the right, but okay, this is actually cooler than you think. Hang on a second. So our documentation system is, this is a Go doc. This is all from a Go doc comment in the code directly. Our documentation system, it's type aware, plugin aware, and strongly versioned. So here you can see the top of the JSON structure along with interactive rich tips explaining what each field is and does.
From the code.
From the code, I pushed a button to generate this. And it can associate Caddy plugins with their Go types and vice versa. It can extract Go doc comments for types and struct fields and read struct tags to know JSON representation like this. So it's basically Go doc, but for a JSON, it follows a JSON structure rather than a Go type structure. It also knows which plugins can be used where. So for example, let's say I want my logs to be encoded in a different format. I can hover this and see which kind of oh, I see. So modules in this namespace can be used here. And these are the modules in that namespace that are available. So if I want to see how to use the HTTP app, I can click on that and I can view the HTTP app documentation. And I can see there's a lot of options here for me. And I can quickly browse and see which ones are relevant and what they do. This is all super spiky, by the way. I literally just like hacked on this for the last week. It's not, it's gonna look way better. And it'll work way better too. But you know, like let's suppose I'm building a handler route and I want to know, okay, well, how can I match requests? Well, I can use all of these methods to match a request. Path, the method, the host, query string, the headers, whether files exist. I can even write a Starlark expression. It's an embedded scripting language and like control this. And you can also, if you haven't noticed, you can click through and zoom in and out of the structure arbitrarily. I can see what kinds of handlers there are. So HTTP handlers for authentication and caching, encoding, which compresses the response. The reverse proxy, by the way, is super cool. Look at all these options for the reverse proxy. Health checks, upstreams, load balancing policies, of which there are a lot. All your load balancing policies so far. Circuit breaking. What kind of transports are there? Well, there's HTTP, and there's NTLM, and there's fast CGI, but I don't know why it's not showing up here. Anyway, lots of really cool stuff here that we're working on. So this will include all third-party plugins as well. In the future, we'll be able to use this technology to analyze your own Caddy 2 configs and explain what they do, and maybe even provide linters and vet style checks. I've never seen anything like this before, ever, on any kind of project. Oh, look at the breadcrumbs. And I want to have like pop downs in the breadcrumbs so you can just navigate, like if I wanted to see what fields were on the HTTP app, I can just navigate there without having to click on it. So this is really exciting. And so Caddy 2 documentation will be getting a lot better. But really, I hope that you will get on board with this project if you think this is cool. We need more collaborators. We have a great community. And Caddy 2 is really, it's a fun project. There's a lot of really cool stuff there. So I'd be happy to help orient you if you want to get started, or if you want to sponsor the project. It's another great way to help as well. But we hope that your business will be using Caddy 2 next year when we come out of beta. Anyway, thanks so much for staying awake. Holy smokes, it's 7:20 already? I'm done. So I'm very more than done. If there are questions, I'll take questions.
So this is in a branch that's pushed to GitHub, or
No, this is
all your own private thing still?
This is still on my, I don't even think I've made a backup of this yet. I should do that.
Yeah.
Dude, it's gnarly. Crawling around the Go AST and the types package is like kind of gnarly. This is fun though, figuring it out. It's black magic, but it works.
It's kind of like API docs for your config, right? It's like Swagger, but for your config.
Yeah, like your config is your documentation.
Yeah,
as well.
Really cool.
Yeah.
So it sounds like you picked JSON as your like intermediate format. I also saw you mentioned Starlark. Are you familiar with it? Like, did you debate those two formats? Because Starlark's starting to be a pretty big driver.
We looked at Starlark, and at first, actually, when we were still considering imperative languages for config, we were actually just wondering, should we just use Go? It can be interpreted, so why not? We ended up with Starlark as an embedded scripting language inside our declarative config because it doesn't use a VM, which is awesome. And in some of our early tests, don't tell anyone this, but some of our early
This
tests.
is being recorded and going on YouTube.
Oh, shoot.
You want this to not go on YouTube? It cannot, but it is being recorded.
We just found that in some of our early tests, the thing is I can't substantiate this right now. You just have to trust me. Some of our early tests, we found that Starlark dynamic handlers, HTTP handlers written in Starlark, executed by Caddy, were twice as fast as Nginx of Lua. So if you have this like dynamic handler need, Starlark's really a great option. And it's familiar, right? It's Python, basically. So Starlark is great.
Yeah, it's good escape hatch. We had to work on it too. We had to have an escape hatch from the escape hatch. If you go to the imperative driven thing, it gets real tough. So I guess that was probably the biggest way to just do imperative.
Switching to imperative is like, it's a total mind shift, but we really want to integrate more Starlark. So I'll talk to you about it because I'd love to know more.
So once this is on the internet, will that be true now?
You guys yelling at us. I'm just telling you what I saw one day as we were spiking it out.
So with your configs, are you guys gonna have some kind of like audit logs or versions or things like that? I mean, is that something that's, I don't know.
That's a great idea. So like a log of all the config changes. Yeah, that's a good idea. We have really powerful logging now in Caddy 2. We're using the Zap library, and we've built in a lot of modules for it. Like you can configure logging almost completely through Caddy modules, and it uses Zap under the hood. And so we can add easily fields for config before, config after. We already log all requests to the admin endpoint. Their headers and bodies and stuff, but yeah, I mean, that's definitely doable. And that's the cool thing, like all the feature requests that people have so far, it's like, oh yeah, we can handle that. The design can handle that. It's basically just add more struct fields or whatever, and it just automatically documents itself.
Cool. Do you have any examples so far of people using it to run long-running programs as a platform?
As a platform, so there
I'm intrigued by that, but I would be down
Yeah.
to start it on my own.
Well, I have some personal ideas that I would love to do when I have time. So for Caddy 1, there's a plugin. It's a supervisor plugin. It's a process supervisor. So it's a long-running process that spawns other processes. You can manage your sub-processes that way. In Caddy 2, I'd love to see a similar type of thing where you can like kind of a cron replacement or a system D replacement. Would be awesome with a little API, like, right? Like, this is cool because you get the API for free, right? And the config and the docs and the online real-time changes. All you have to do is write the code now. And so Caddy's that kind of platform. Yeah, I would love to see more of that in Caddy too. Great. Well, thank you so much, everyone.
Thanks again, Matt. So for you have food and stickers and pins, and you can hang out as long as you want, and you can ask Matt questions, or just chat, or do whatever you want. And we'll see you next year. I can say it because it's December.
Yes.